I am Mondira Sahamal Downey. I'm the Department Administrator for Biomedical Engineering. What a glorious day to celebrate this 25th anniversary through the symposium. Thank you for joining us. I'm going to introduce you to Dr. Paul Campagnola, our Department Chair for Biomedical Engineering. Paul Campagnola obtained his PhD in chemistry from Yale University in 1992 and was a postdoctoral associate at the University of Colorado from 1992 to 1995. He has over 100 peer-reviewed journal articles, several review articles, and book chapters, and he co-edited a book, Second Harmonic Generation Microscopy. His research focuses on modifications in the extracellular matrix in diseases, including cancers and fibrosis. Welcome, Paul.
All right, thank you, Mondira, for that kind introduction. I'll be brief. I just want to welcome everyone here. We have a great program, so thank you to everyone for coming. Alums, I'm hoping you get a chance to see each other. I just want to give a couple quick thank you, especially to Mondira and our staff who've worked on this since about February, and so it's really come to fruition very nicely. I'd like to thank my co-chair, Felice, in the front row, who put together a lot of the program. I also want to thank, unfortunately, they were not able to attend. I want to thank the Tong family for all their generous support over the long time, for overall the department, and also then endowing the chair position that Justin Williams secured about 5 years ago. So just a big thank you, to the Tongs. I just want to point out, this is I think it's an exciting time for the department. It's not just our 25th anniversary. We're in a period of rapid growth. So when I moved here in 2010, the whole undergraduate program was about 150 students. Our entering class 2 years ago was 260. So even with students moving in and out, we have more than tripled our undergraduate population in the last 15 years. So we have the second biggest undergraduate population next to the dreaded Michigan. So we've really there's a lot of Michigan alumni in here, so especially in our department. So we have really grown. We're in a hiring phase. We have 4 new positions this year we will be filling. I think most of you have probably seen there's a new building coming. The official naming will be tomorrow, so look to see who the name of the building is. I have no idea. And to accommodate our growth, though, it's kind of an older building. We're actually going to be colonizing the McCardle building. We're getting a couple, parts of a couple of floors. So we are definitely in a growth mode. So this is a great time to be here. So with that, we'll get on with the program because we have schedules. So I'd like to introduce Bill Murphy. And so Bill is going to give a historical retrospective of the department because at this point, Bill joined the faculty, I think in 2003. 2004? Okay, but definitely one of the originals. I'll read Bill's quick bio. He's a Harvey Spangler Professor of BME and Professor of Orthopedics. He also has a fellowship. His group does tissue engineering and biomimetics. They have over 200 papers, 60 patents, has co-founded 4 startup companies based on all that. And more recently, he's been the founding director of the Forward Bio Institute, which has been a very good partner with BME. So let's give a big welcome to Bill Murphy.
Well, thanks, Paul. And it's really my privilege and honor to be able to give a little bit of a historical perspective. I'm really not the right person for this. The right people for this are going to be in the panel right after this talk, and they can correct all the things that I get wrong in my description of the history of the department. And so my caveat at the outset here is I'll give a bit of the history, and then I'll also give a little bit of what I would say is my individual perspective on what makes BME special. And the caveat is that any faculty member in BME would have their own list of things. This is just my opinion on what makes us special as a department and as a community. So first, a brief history of BME at Wisconsin, and it goes back quite a bit longer than probably most people would realize. So as early as the 1950s, UW's history of BME research and education began. And in the 1960s, there were several UW faculty members in multiple departments that had BME research and teaching interests. So the sort of infrastructure intellectually around BME was starting quite early on. In the early 1970s, a multidisciplinary faculty from across the campus, primarily from ECE and from medical physics, created a new BME master's program that had a curriculum that was customized to each student and had a physiology requirement. So this was consistent with the way master's programs in BME were being created around the country. So this was the very early history. In the 1990s, and I'm going to be irritating here, and because it's early in the morning, I'm going to ask for some rounds of applause. So when I ask you to applaud, please applaud. So in the mid-1990s, so we had in the 1990s a group of visionary founding fathers who would not take no for an answer, and you're going to hear from them in the next panel. But in the mid-1990s, Professor Robert Radwin from industrial engineering suggested that the university was lagging behind other major universities in BME education. So Rob Radwin, who's right here in the front. Professor Willis Tompkins from ECE began joining in those discussions on how to develop a new department here. Willis Tompkins sitting with Rob right here. The late Professor John Webster from electrical and computer engineering had been developing courses and educational content, including multiple textbooks, in BME since the 1970s and also joined. John's no longer with us, but was an incredibly important influence early on, John Webster. And then this is actually my favorite part of the story. So the graduate school appointed a committee to study the BME MS program in biomedical engineering, and the consensus was that they should kill it. Is that there's not enough master's degrees being produced, and the program should no longer exist. Professor Ray Vanderby from orthopedics and rehabilitation was on that committee, decided he disagreed with them, resigned from the committee, and joined Rob and Willis and John to start talking about the new department. So Ray Vanderby. So there is a history of the 1990s in BME that would take this entire 30-minute talk. And so I'm not going to go into detail on this. I'm going to encourage you to ask the true founders of the department questions about this as we go through the day, and they'll describe some things during the panel discussion as well. But here's a canned question for them. How many barriers did you circumvent to establish the Department of Biomedical Engineering? You can count at least 7 no's from deans, from people across the campus, and ultimately they were able to make this happen. So we're all here because of these people. So thanks so much to them for being the ones who really pioneered this and had the vision that's produced what we're doing today. So thank you. So if you're a history buff, these 4 are the Mount Rushmore of biomedical engineering. So there they are, right on Mount Rushmore. If you're a music fan, then these are the Beatles, right? So there's the Beatles of biomedical engineering, okay? Okay, so then 1999 to present, I'll say just as an initial comment, there never was a dean who walked into UW-Madison and said, biomedical engineering is my priority, here's 20 faculty slots, go and grow. That never happened. So the people who started the department and the people who continued to lead the department had to grow entrepreneurially, had to be creative, had to work with folks across the campus to identify faculty slots in areas of impact and to grow the department. So these are just some examples of those creative efforts. So the initial founders secured a Whitaker Foundation grant to establish the department and initially recruit a couple of really high impact faculty members, including Dave Beebe, who's still here. Bringing in faculty co-appointees with other UW departments, so creative co-appointments allowed us to have people move portions of their appointment to BME and to recruit new faculty that had co-appointments. And then this campus-wide cluster hire initiative that's designed to try to grow the university in areas of particularly high urgency and impact was perfect for BME because that's what the department wanted to do as well, and resulted in a number of new faculty hires over time. Finally, the integral involvement of BME faculty in building the WID, the Mortgage Institute, and WIMR resulted in strategic growth opportunities as well. And you can see lots of faculty who are now having enormous impact on our community here and in our department. And then also, obviously, primary BME hires have allowed us to anchor new research and teaching areas over time. So there has been a commitment of the college and of the university to BME specifically, but I just want to emphasize that this creative, collaborative strategy is what resulted in what you see in the department today. Okay, so a scientific analogy to what we've done so far in biomedical engineering, and I'm using vascular morphogenesis because our very newest faculty hire, Duke, where's Duke? There's Duke, just got here within the past month or so, right? Is studying and manipulating vascular morphogenesis. So this is our analogy. Right at the top of the morphogenetic steps here are Rob Radwin and Willis Tompkins, right? So right at the top there. They've recruited other endothelial cells from throughout the university and around the country. They've now started to assemble into a network. You can see in this movie in the middle, these endothelial cells that Rob and Willis recruited starting to assemble into a network. And then ultimately you have this network of endothelial cells that are all connected to one another, okay? So that's a very brief history of BME at Wisconsin. It's vascular morphogenesis, and now the department, by the time they had completed the recruitments, was ready to vascularize the rest of the institution. Okay, so again, the caveat is this is just my perspective. I haven't cleared this with anyone. This is what, in my opinion, makes Wisconsin biomedical engineering special. We pioneer innovative teaching and training. We solve important real-world problems. We maximize the impact of our technologies, and we create interdisciplinary communities. So I'll spend a little bit of time on each one of these concepts. So first, we pioneer innovative teaching and training. So the founding fathers of the department decided on a curriculum with specific depth areas for each student based on suggestions that they had from industry contacts. So in these initial discussions, they already had input from industry. How should we be training our students? Importantly, in the second bullet point, this is something that very few departments, I think, have probably ever done as they're being created in a College of Engineering. There was a concern from industry folks that there wouldn't be enough engineering depth in biomedical engineering. And to address that, rather than saying every BME student has to also have a mechanical engineering degree or also has to have an electrical engineering degree, what the founding fathers decided to do was emphasize things that engineers typically have to learn on the job. And this has permeated our entire program, from the undergrad program through the graduate program. Open-ended problem solving, team experiences, and oral and written technical communications. Okay, so, and if you think about it, if you're an alum from the department and you're successful in industry or in academia, probably those skills drove your success every bit as much as your technical training did. So that was a really important innovation. And then based on the prior teaching experiences of the founding members of the department, they decided to implement design throughout the curriculum as a signature feature of this program. And that's been really an example for departments throughout the country to follow. The design throughout the curriculum was a very, very important innovation and something unique to BME here at Wisconsin. So what have we created over time? A number of degree programs, including a brand new, just in the last few years, MS in Biomedical Engineering, Innovation, Design, and Entrepreneurship, the BIDE program. We've undertaken prolific course creation. So because we were a new department, basically we had to create an entirely new curriculum, and that meant that new faculty coming in could create courses in areas that didn't currently exist or didn't have coursework that existed. So areas like neuroengineering and stem cell engineering, areas where we could innovate, create content, and then create new coursework. So it was challenging to create a new curriculum, but it was also an opportunity for the department to really be innovative in teaching and training. And then establishing tracks that directly connect to a student's impact on society and industry and in medicine. Okay, so second, we solve important real-world problems, and this really is exemplified most directly by the BME design program, which was developed and pioneered by Willis Tompkins, was expanded and further developed by John Puccinelli, who runs our undergraduate program. To date, there have been over 1,000 BME design projects involving over 1,500 students, which is just a tremendous, remarkable impact. If we were here 50 years from now and those were the numbers, it would still be impressive. It's incredible how many projects have been completed. Every single one of those projects, as you all know, produce a prototype, which is remarkable as well. Just in fall 2024, we have 72 design projects, so that's a remarkable number as well. We also have a new BIDE program, as I mentioned, that has about 20 students a year and is growing, and that's a program that's directed by Darila Suarez-Gonzalez, who runs our master's program, and this has an opportunity to essentially do what we've created in BME design at the undergraduate level and apply it at the graduate level and expand it into areas like entrepreneurship, so that's quite exciting as well. So we're driven to solve these important real-world problems, and we practice what we preach. Some additional fun facts about the BME design program from the past 3 years. So 31 patent disclosures, 24 industry-sponsored projects, 6 patent filings, 147 unique design projects, 3 companies formed, and 797 students. Excuse me. The remark I'll make here is if this were the entire department's output, it would be very, very impressive. If we didn't have a graduate program or any faculty doing research, this by itself would be impressive. So it's remarkable the kind of output that comes every semester from BME design. Third, we maximize the impact of our technologies. So by traditional standards, BME faculty are excellent. I think everybody in this room hopefully knows that. Things like publications, presentations, research funding are all good. Over half of the primary BME faculty are AIMBE fellows, which puts them in the top 2% of BMEs around the country. But one way that we really set ourselves apart in BME is our societal impact. So there's no guarantee that publications and presentations result in societal impact unless it's intentional. And primary BME faculty have filed 280 patents, have 25 actively licensed patents to companies. And then maybe even most notably, primary BME faculty have started at least 20 companies to date. So that's a remarkable number, probably larger than just about every BME program in the country. Here are some examples of those companies, and this is probably not a complete list. I don't know if Dave Beebe or Justin Williams have started a company this morning. It's possible, we don't know. What time is it? It's about 8:30. They probably have. So there's been a lot. There's been a lot of innovation. You're going to hear more about those in a panel discussion later on. Excuse me. We create interdisciplinary communities. This is the fourth thing that I think we've done really, really well in BME over the last 25 years. So we've had prolific collaborators and innovative, inclusive leaders. I've heard Kevin Elisari described multiple times by Brad Schwartz, who's the mortgage director, as the most collaborative person on campus, which I think is a very apt description of Kevin. But I would say any list of the top 10 or 20 most collaborative people on campus would include probably 5, 6, 7, 10 BME faculty. So we are, in many ways, a glue that holds together collaborative research areas on campus. So virtually every major research initiative at UW has involved BME faculty in the past 2 decades. We have faculty with co-appointments in countless departments. I didn't bother trying to count, there's just too many. And we're driven to innovate not within our discipline, but across disciplines. And I think this is really an important distinction for us. Most BME departments do a lot of collaboration and team building within their department, but much less outside of their department to create new programs. And I would say building communities within BME would be much more comfortable. It'd be much easier. And that echo chamber can be very comfortable to live in because everybody's got kind of the same mindset about solving problems. What we've done is the much less convenient and more difficult program building across the campus. So I think that's really quite an important distinction here. So we've permeated the entire UW campus. We exist in buildings across the campus. We collaborate with folks around the entire UW campus. And in that sense, our initial vascular morphogenesis has vascularized the entire university, okay? So this is the next step in that analogy. A few specific examples I want to highlight is basically 3 new buildings that became BME driven in many ways, okay? So we have multiple faculty that are in the Wimmer 1 and 2 towers that have their lab space there and are driving collaborative efforts there. The WID and the Mortgage Institute both were driven in some ways by new BME hires as well as existing BME faculty. And then the Engineering Centers building, which was never intended to house a department, it was expressly almost forbidden from housing a department, was the initial home of biomedical engineering. So amazing again that people like Rob Radwin made that happen. They didn't want to put a department there, they ended up doing it. So not taking no for an answer. And here are some examples of campus-wide programs that were either created by or led by BME faculty over the last 20 years. And you recognize probably all of these. It's a remarkable scope of impact that BME faculty have had across the institution. And I'm sure I'm missing some. Again, Chris Saha probably created a new collaborative program this morning, and I just don't have it on here yet. Okay, so that's again my perspective on what we do well and what has been special. I really hope that this is a launching off point for discussions that you'll have during the course of the day today. What's your own favorite thing that's special about biomedical engineering? What's your perspective on what we do really well, what we do that's different than what other people do at other universities? Okay, so how it started and how it's going. So in 2000, we had 4 founding faculty, 11 undergraduates, and no grad students. Now we have 24 faculty, 54 affiliates, 5 teaching faculty, hundreds of undergraduates, over 100 graduate students, and thousands of successful alumni, many of whom are represented in this room. So thank you all for being part of building what we've built here at UW-Madison. So this is possible because of an incredible staff. So this is a listing of the staff members in biomedical engineering. You've already heard from Mandira, who's our fearless departmental administrative lead, but there are loads of folks who make the trains run on time and help us innovate in biomedical engineering. I'll say that this department in particular is an incredibly difficult one to administer because everything is changing all the time. We change things, almost every faculty meeting, something changes, right? And so if you were an administrator for a department and you weren't willing to be responsive to that and excited about change, this would be the most frustrating possible job, right? So it's very, very difficult, and these are people who make it look easy. So thanks to our staff, an incredible, incredible group of people. And then there's so many staff members over time that we can't acknowledge all of them, but I want to make sure and acknowledge our administrative leads over time, starting with the legendary Corrine Barr, who was involved in helping to recruit and set up a lot of the faculty at UW and making it a comfortable home for people, really building it into a comfortable home for everybody. And then Suzanne, Joan, Kelly, all have kind of taken the baton and helped keep the department running really, really well and making it a welcoming and inclusive and enjoyable collegial environment. So thanks to all of them. So what could be next? There's lots that we have left to do. This is not the end, and as Paul indicated, we're in a growth phase in many different ways. We have dedicated faculty leaders, Paul, Chris, and Felice. Oh my gosh, sorry Megan. That's Megan McLean. That's a copy and paste issue. That on the upper right-hand side is Megan McLean. Is Megan here? She's not here? Okay, well then never mind. I can offend somebody who's not here. We have extremely highly innovative new faculty who are launching off into new directions. So 25 years from now, the stories will be even better than they are now. But Arushi, Josh, Duke, Felice, oh my gosh, I've done it again. Aviad, hi. Felice, you're everywhere. So this is what you get if you're the co-chair of the meeting. And Colleen Witzenberg. So it's a wonderful group of young faculty who all have individual names. They're not... Okay, so our vision, as we've structured it and agreed upon, is to improve human health by integrating education, discovery, innovation, and entrepreneurship. So obviously, that creates tremendous possibilities for the next phase of BME. And we're driven by the Wisconsin idea. Our impact is meant to amplify worldwide. That's our plan. And with help and support from alumni and from other stakeholders in BME over the next 25 years, we can achieve anything. Last, I'll just make a few acknowledgments. Oftentimes the acknowledgement slide lists people's names. There are thousands of people that have been part of BME over time. But I want to thank the faculty for creating and disseminating ideas that can change the world. So thanks to our faculty. Our staff for guiding and supporting our complex and evolving BME vision. Our students for routinely achieving the impossible. And most of all today, in this celebration, to our alumni for exceeding our wildest expectations and making us all so proud. Thanks so much for being here. Okay. So that's the end of my path through BME's history. Now you're going to get to hear from the people who actually know what was wrong with what I explained and can correct all of the mistakes in the description of the last 25 years. So it's my privilege now to introduce Rock Mackey, who's going to moderate our fireside chat with the founders of the department. Rock is a prolific inventor and entrepreneur, as you all know. I don't think requires a detailed description of his history at UW and beyond. But Rock was a faculty member at UW from 1987 to 2014, and his last role was Director of Medical Engineering at the Morgridge Institute. He's won a variety of awards, including being a Fellow of the National Academy of Inventors. And he started a number of companies, maybe most notably Tomotherapy, but is also a co-founder of Leo Cancer Care, which is now developing upright radiotherapy, OnLoom, a fluorescent-guided surgery company, and he's a board member at Shine Medical Technologies, developing medical isotopes using fusion and fusion nuclear reactions. So thank you, Rock, for moderating the next session, and welcome.